Dear students, in our previous online interaction, we were understanding about anatomy of an atom. J.J. Thomson proved that an atom is divisible. We also understood under what conditions gases conduct electricity and atoms are broken. We learnt about cathode rays. Important point in this was cathode rays are stream of negatively charged electrons. Electrons are discovered by J.J. Thomson. Then we understood E by M experiment by J.J. Thomson and E charge by Millikens experiment. Again, one important highlight of this E by M experiment is E by M was the same for all the samples he has taken. Before we proceed further for today's discussion, let us watch a very small video of about 2 minutes on Millikens experiment I have selected for we all.
Millikens Oildrop experiment. British physicist J.J. Thomson had measured the ratio of electrical charge to the mass of an electron using a cathode ray tube in 1897. Later, R.A. Millikan looked to determine the charge on the electrons. The famous method that he devised between 1906 and 1914 to measure the charge E of an electron is known as the Millikens Oildrop experiment. Using this method, he calculated that the charge on an electron was about 1.6 times 10 power negative 19 coulombs. In the Millikens Oildrop method, an atomizer produces oil droplets in the form of mist, which are sent through a plate of electrical condenser. There are different forces which act on the oil drop, including gravitational, electrostatic force due to electric field, and viscous drag force. The rate at which these drops fall were measured by observing them through a micrometer eyepiece of a telescope. X-rays were passed through the chamber to ionize the air inside. On colliding with gaseous ions, these oil droplets acquire charge. The rate at which these droplets fall can be controlled by changing the strength of applied voltage to the plate. With this experiment, he observed that the magnitude of electrical charge Q on the droplets is always a multiple of electrical charge E. That is, Q is equal to NE, where N is equal to 1, 2, 3, and so on. Using the value of charge of the electron, the mass of the electron, ME, was then determined by combining Thomson's value of E by ME ratio. The value shown is the value of the mass of an electron.
I think you have understood how Millikens did his experiment. This is just to bring to our mental picture how it was conducted. Now, today's discussion. Once we understood that an atom is divisible after discovering electron, now people thought that when a negative charge is there in an atom, then there should be positive charge, because we understood in the previous class, or this information was there before J.J. Thomson, that an atom is electrically neutral. When an atom is electrically neutral, when negative charge is there in an atom, then positive charge has to be there. So therefore, people started thinking or discovering on the positive part which is there inside the atom. So this led the discovery of what? Another type of rays known as anode rays, and this was the work of Goldstein. J.J. Thomson did cathode rays. That time he was concentrating only on the cathode rays part. So he was at the same time something was happening in the same test tube, in the same discharge tube, but he could not notice, because when we think on a particular topic, so we will pinpoint out the concentration. In the same way, J. Thomson was concentrating only on the divisibility of atoms. Okay. Now you see the other part which is happening inside the same tube. This is done by the Goldstein after some gap, so that we can explain the atoms neutrality. Discovery of anode rays by Goldstein. Discovery of an electron by J.J. Thomson and anode rays by Goldstein. This is the discharge tube, same discharge tube, right? And see, this is the anode and this is the cathode. As usual, vacuum pump to create the low pressure and plus minus so that he can maintain high voltage. Now, this is the slight modification of the what? Cathode. What modification? Here he has made perforations, holes, so that whatever rays are formed, they are allowed to move in a systematic way, disciplined way. So that was his arrangement, so that whatever rays come this side, he can study aramse. Conditions are same, very low pressure and very high voltage. Electrons are ejected from the cathode, right? When electrons are ejected, they interacted with the remaining atoms of the gas. Thereby, these formed electrons or the formed cathode rays ionized the gas present inside the tube. So because of ionization, more and more electrons are formed. When any atom loses electron, it becomes positive. So here in this area, because of ionization, not only electrons are formed, positive ions are also formed. Because electrons are negative, they move towards the anode. Because positive ions are because they are positive ions, they move towards the cathode, which is negative. Okay, so see, this is positive moving towards cathode, negative moving towards the anode. But instead of moving randomly, so here they are moving disciplined way. Okay, so these are the rays. So these rays, he thought that they are coming from the anode. So actually they are coming from anode. That means he named them as anode rays. Earlier one was cathode rays. Now these are called as what? Anode rays. And Goldstein also named these rays as canal rays. CANAL, canal rays. Why? Because see, in the canal, when you leave the water from the dam, how systematically it flows from one end to the other end. In the same way, he has made some arrangements so that these rays were moved, allowed to move systematically. So that's why it was looking like as if a channel is moving, as if a canal is moving. That's why he named anode rays as canal rays. Let us see. When the high voltage is applied to the tube, it ionizes the gas present in the tube at very low pressure, same conditions. The ions produced collide with atoms of gas, knocking electrons, creating more positive ions. Electrons ionizing the matter, that is gas, into electrons and the positive ions, they collide themselves again, many more ions, many more electrons are formed. That is the idea. These ions and electrons in turn strike more atoms. So this will continue. It is like a chain reaction, creating more positive ions which are attracted to the negative cathode. These rays are called anode rays. So the credit of anode rays goes to Goldstein. Anode rays pass through the perforations, holes, channels in the cathode. So therefore Goldstein called them canal rays. Properties of anode rays. Same, only thing is cathode rays, anode rays are slightly heavier, okay, and they are attracted by, because they are positive, negative, remaining the same, right? So all the properties are same, traveling in a straight line, kinetic energy, attraction and magnetic field slightly differs, okay. So this is little information about the anode rays by the famous scientist Goldstein. Nature of anode rays depends on the nature of gas inside the tube. This is very important point. In the case of cathode rays, you take any gas. Cathode rays are the same, but here anode rays, the nature is different. If you take hydrogen gas inside the tube, then the anode rays are nothing but protons. Why? Hydrogen atomic number 1 with 1 proton, 1 electron. When it loses electron, it becomes proton. Therefore, if you take hydrogen in the tube, after removing electron, whatever left is called as a proton. But if you take other gases like carbon dioxide, helium, neon, argon, many other gases, when you remove some electrons, directly one proton is not found. Some protons and neutrons are also there, no? So it is called as positive ion, not a proton. In the case of only hydrogen, if you remove electron, it is a proton. In the case of other gases, by removing electron, it is called as a positive ion. That means this is the nature of anode rays. It depends on what? Depends on which type of gas you have taken. If it is hydrogen, anode rays are protons. If it is other gases, anode rays are positive ions. That is the most important difference between cathode rays and the anode rays. Some captions regarding the proton. If you want to stay positive, think like a proton. Protons give an atom its identity, electron its personality. That led to the discovery of. These are the data regarding the proton. This is the charge of the proton, mass of the proton, EYM of the proton. Okay, so a proton is a subatomic particle with a mass defined as 1 and charge of +1. And the smallest and lightest positive ion was obtained from hydrogen gas and was called proton. So here first he took the CO2 gas, then he took the helium gas, then he took the methane gas. So he tried with all possible gases, but the smallest and the lightest positive ion he got from which type of gas? It is the hydrogen gas. Why? Hydrogen gas, that is the hydrogen atom, after losing electron, it is the lightest particle, that is the proton forms. So anode rays are, once again I am saying, protons only in the case of hydrogen.